So today, guys, we're going to talk about the average value of a function f of x, and it's really simple. You get it using this formula, 1 over b minus a of the integral from a to b of f of x dx. Now, notice if you want the average value of f of x, that means you're going to be integrating f of x, or finding the area under the curve if they were to give you a graph, or you can use them in sum if they're going to use a table. And you're going to take whatever you get for that integral, that definite integral, and you're going to divide it by the length of the interval. Now, once again, just to emphasize, excuse me, if you want the average value of f of x, you're integrating f of x. Let's just say you wanted the average value of velocity. Let's just say you wanted that average value of velocity. Then instead, you would integrate, well, what would you integrate? You would be integrating velocity because that's what you want the average value of. Or if you want the average value of, let's just say instead, f prime, then you would be integrating f prime of x. So whatever you want the average value of, then you're going to go ahead and integrate that particular function that you want the average value of. And if you think about it, what's the antiderivative of velocity? Well, that would be position. So we would say that would be x of t, that's the antiderivative velocity, and we'll say from a to b. And of course, we're dividing it by b minus a, the length of the interval, which would be x of b minus x of a, divided by the length of the interval, which was b minus a. So this does relate to the average rate of change. Notice that the average value of velocity would be the average rate of change of position, because here we're finding the slope of position, so this represents the average rate of change of position, and that would be the same thing as average value of velocity. Once again, though, I just want to emphasize that the average value of f would be given by the integral of 1 over b minus a of f of x.